Question: A marble rolls off a table with a horizontal velocity of 1.93 meters per second and onto the floor. The tabletop is 76.5 centimeters above the floor. Air resistance is negligible. A. Determine how long the marble is in the air. B. Calculate the range of the marble. C. Calculate the velocity of the marble when it hits the floor. So the initial velocity is 1.93 meters per second. And the angle between the direction of the initial velocity and the horizontal surface, the horizontal line, is 0. Because the marble rolls off with a horizontal velocity. And we set the 0 point on the surface of the table. Here is the 0. The 0 point is on the surface of the table. Then this is positive y direction. This is positive x direction. And the floor is here. This is the floor. So from the tabletop to the floor, this distance is 76.5 centimeters. So we know the vertical displacement delta dy is negative 76.5 centimeters. And this equals negative 0.765 meters. It's negative because the marble rolls off the table and the marble goes down this way. So the direction of its vertical displacement is opposite to the positive direction. Then for question A, we have this formula. The vertical displacement delta dy equals the initial velocity multiply sine theta and multiply delta t, the time interval, minus 1/2 multiply acceleration g multiply delta t squared. Now we put the values in this formula. So delta dy is negative 0.765. And this equals the initial velocity is 1.93 multiply sine theta is 0 degree multiply delta t minus 1/2 multiply acceleration g multiply delta t squared. And we know sine 0 degree equals 0. So from this equation, we can get that the delta t just equals square root 2 multiply 0.765 divided by the acceleration g. G is 9.8. Then delta t equals 0.4 seconds. Then for question B, it asks for the range of the marble. The range is just the horizontal displacement. We have this formula. The horizontal displacement just equals the initial velocity multiply cosine theta multiply time interval delta t. And this equals initial velocity is 1.93 multiply cosine 0 degree multiply 0.4 seconds. And this equals, we know cosine 0 degree just equals 1. So at last, the horizontal displacement is 0.77 meters. Now for question C, it asks for the final velocity. So we need to find the final horizontal velocity and the final vertical velocity. Now we use them, we can get the final velocity. So the final horizontal velocity just equals the initial horizontal velocity and equals initial velocity multiply cosine theta, and this equals 1.93 multiply cosine 0 degree, and equals 1.93 meters per second. Now we have this formula. The final velocity, vertical velocity, equals the initial velocity multiplied sine theta minus acceleration g multiplied time interval delta t, and this equals 1.93 multiplied sine 0 degree minus 9.8 multiplied the time interval 0.4 seconds, and this equals, we know sine 0 degree equals 0, so at last the final vertical velocity is negative 3.92 meters per second. It's negative because its direction is down. It's opposite to the positive direction. Then I draw them here. So this is the horizontal final velocity, and this is the final vertical velocity, and this is just the final velocity, and this angle is theta. This angle is 90 degree. This is a right triangle. So from this triangle, we can get that the magnitude of the final velocity just equals square root the magnitude of the final horizontal velocity square plus the magnitude of the final vertical velocity square, and this equals square root. Now it's 1.93 square plus 3.92 square, and this equals 4.737 meters per second. And the angle theta equals arc tan theta. Now the top is the magnitude of the final vertical velocity. Bottom is the magnitude of the final horizontal velocity. And this equals arc tan theta. Here, this is 3.92. The bottom is 1.93. And this equals 63.79 degree. So the final velocity is, its magnitude is 4.37 meters per second, and its direction is 63.79 degree below the horizontal. It's because this direction is horizontal, that is below the horizontal for 63.79 degree. Oh, here.